Can you believe I did do that? Well, James, you should have been here today. You missed it. And I forgot to share it. Oh, well. You should have been here. You were absent in my class. Damn it. Sorry, James. You missed out. Yes, Aunt. Anybody have any good notes that they could send, James?
I can.
Thank you. That would be awesome of you to save my ass. Okay. Let's go back to here. Okay, so the Coriolis force and the pressure gradient, if these two forces are balanced, what do you know about the velocity?
It's going to be perpendicular to, I think those are isobars, right?
Yeah, they were assuming they're isobars or isoheights. No. If the two forces are equal, which we said in geostrophic wind they are, then what is true about the velocity? What did you say, Allison? Did you guys hear Allison, or is it just me who can't hear her?
I can't.
No.
Both sides.
I heard that, Allison. I heard your keyboard.
I don't understand.
There,
We
now
can hear you
There
now.
we can hear.
But it's constant.
it's the velocity is constant. What's another way to say the velocity is constant? Doing what's it not doing?
Doesn't change speed.
And it's
Direction.
not. And therefore it's not.
Accelerating.
And if it's not accelerating, what's another way that you can describe that? What's the,
Geostrophic.
what?
Geostrophic.
No. If it's not accelerating, what are the two ways of describing a motion? Accelerating or
Direction.
what's the opposite of accelerating motion?
Deaccelerating.
No, that is not true.
If it's not accelerating, then it's the velocity is not changing. The
Right.
speed is not changing. Direction is not
There's a
changing.
word for that. Constant velocities, straight line, constant speed means the air is what? Now see, that's why I like teaching intro this way. It's inertial. The word's inertial. A motion is either accelerating or it's inertial. That's it. So if there's no force, the velocity is constant. If the velocity is constant, the air is not accelerating, which means it's inertial. Inertial motions are straight line at a constant speed. So do you see that the air motion would travel at a constant speed in a straight line, which means where is the motion going? Toward what?
Crossing larger isobars.
Toward what?
Toward the east.
Toward
Higher pressure.
higher pressure,
Air
right?
pressure.
It's going toward higher pressure. So we know this must be low pressure because it's moving that way, Weisbach law, right? This is low pressure. So it's going to travel toward higher pressure, which means it's going opposite the pressure gradient force, which means it's going uphill, which means what's the air going to do?
Whoa.
It's going to slow down, isn't it? It's going to slow down. So there's going to be a change in the velocity to bring it back into geostrophic, and back into geostrophic says it's going to be, oops, wrong color. Means it's going to go back to being parallel to the isobars, so, which means that there's going to be this, which is a what? A change in the velocity. But do you agree that why is there a change in the velocity? Because it's going toward, it's going to come back toward lower pressure. It's going outward toward higher pressure. So if it's going outward, there's that concept that it's either centripetal or centrifugal. And this velocity must be slower than this. Right? That the air, because the force is pointed toward low pressure, then the air slows down, slower than this velocity. But what was this velocity? What was the velocity? It was going in a straight line. So what would you call that velocity? That's geostrophic. It's slower, the actual velocity is slower than geostrophic, which means we call it what? Subgeostrophic. Which means the pressure gradient force is being balanced by the Coriolis force plus the centrifugal force. Which means
Is that R sub t in the denominator of the second term?
what do you think R sub t stands for?
The radius of a tangent?
No, the radius of what? What radius matters? Go back to page 275. What do you think T stands for? Right.
The trajectory?
I heard you. I saw you, Allison. I didn't hear you, but I saw your lips. It's the radius of trajectory, because it's the path that the air is actually taking that matters, not the streamline. So if this low pressure is moving, then that's different.
That word PDF equals PDF plus. What is that?
This is the radius of trajectory, not a streamline, right? We're not assuming that the air is necessarily going this direction. Maybe the low is moving. So we have to kind of think about which way is the air parcel actually moving. But when we go here, when we look at this, then what we're going to say is I can look at this equation and I can say that v squared over RT plus 2 omega v sine phi plus 1 over rho PdN. equals 0. What kind of equation is this?
a linear.
Quadratic.
What's the solution for the quadratic?
Two.
1 over square plus minus.
No.
Opposite b, so negative b, plus or minus
plus
square
or
root
minus
b squared minus
4ac.
Ah!
Ugh.
Uh-oh.
That was bad. Thank goodness for the undo button.
It's 4ac over 2a.
So A when I look at A, I'm thinking that the A term is the centrifugal force. When I look at the B term, I'm looking at the Coriolis force. And the C term is the pressure gradient force. But there's a problem. And the problem is in this term here. When does that term become imaginary?
When that,
When it turns out to be negative, or when
Right? Let's just say
when 4ac is
4ac.
greater than b squared.
okay,
Yeah.
when 4a, okay, so if 4ac is greater than b squared, this is negative, and it's imaginary. You can't deal with that. So what I'm saying is, if the Coriolis force is too big, then the centrifugal and the pressure gradient force, then I can't balance it. Under what conditions, however, will this always be solved?
When b squared is greater than 4ac.
No, even without knowing the magnitude.
Oh,
When A and C are of opposite signs,
oh, yeah.
right?
Mhm.
Now, what does it mean for those two to be of opposite signs? It means the centrifugal force and the pressure gradient force point in opposite directions. Does that make sense? Now, in this picture, which way does the centrifugal force point? Do you agree it points outward? Which way does the pressure gradient force point? Inward.
opposite.
Therefore, are they opposite signs? So that means in this equation, this should always be solved. Does it look like they're opposites? This used to get me so confused, I could never figure out how to explain this. And now I figured it out. It only took me, 25 years to figure this out. Are those two terms opposite terms?
Yes.
They should be, yeah.
Why? Well, they should be because they point in opposite directions. But do they look it?
No,
No.
Why do we know that they are?
because that pressure gradient is going in the negative direction. So that term's always going to be negative.
This term is negative. And this term, why is this term positive? Because I brought it over to that side. So that's where that negative sign goes away. This in the box is negative. This is now positive. So whatever it is, I want a negative sign in here. This one will be positive sign. Now, I'm running out of time, so let me do two things really quickly. If this is high pressure, I want you to draw this for Thursday. Make this high pressure, and then which way will the pressure gradient force point? Like, if it's high pressure, do you agree that the air would bleed this way, pressure gradient forces that way, Coriolis forces, I'm sorry, the pressure gradient forces this way, Coriolis forces to the right, and the centrifugal force is pointing this way. So do you agree that the centrifugal and the pressure gradient force are pointing in the same direction? So that means now this may become imaginary. So I want you to draw a nice diagram of that, and then I'm going to give you a problem to do. Shoot, I don't, well, that's okay. I don't need to do that. So let's do this. I have 60 meters change in Z over we'll do what we did before, 200 kilometers. Latitude is 42 degrees. And we have a wave. So the radius of trajectory is 400 kilometers. So I want to know the geostrophic wind, super geostrophic, and the sub geostrophic. Is that all we need? Yes. So basically I have a wave. How fast are the winds on the ridge? How fast are the winds in the trough? And how fast are the winds in between?
And what was that diagram that you wanted us to draw? Just basically the
Yeah, I drew the area of low pressure with the forces, drew the area of high pressure, write up the equation that would be there.
okay.
Now, how many solutions are you going to get? Because you have a plus or minus, you're going to get 4. So I want to know those numbers. So this is super important that you guys do this assignment. I need the answers from all of you. That means you've got to take the time to do it. And I'm going to check your answers. So email it to me. Okay? James, sorry about that. Jim will send you the notes that he's got. Everybody good?
Mm-hmm.
All right, guys. We will see you all on Thursday. Good luck on your test, Al. We'll
Good
see you
luck.
guys.
See you
Peace out.
Thursday. Bye.
Bye-bye.